First up, F1-SCORE. It's like the golden child of precision and recall. When you can't decide which is more important, F1 says, relax, I'll take the average, the harmonic one.
So it helps when data's unbalanced? Like Meg's mood swings?
Exactly. If precision is how many of my guesses were right and recall is how many correct things I found, then F1 is the smart balance between the two. Now, the confusion matrix, it's a 2x2 table that exposes your model's hits and misses. True positives means when model says yes and it is yes. False positives means when the model says yes but it's actually no. True negatives means model says no and it is no. False negatives means model says no but it's actually yes.
So a scoreboard for how confused your model really is.
Exactly, and now the brain bender. Bias-Variance Tradeoff. Bias is the difference between what your model predicts and the actual values. If bias is high, it's like saying everyone's a chicken nugget. It's wrong and oversimplified. That's underfitting. So we want low bias.
So bias is like a lazy guesser?
Yep. Now variance is how much your model's predictions change based on the training data. A model with high variance fits training data too perfectly, like memorizing every cookie in the jar. But then it totally messes up on new data. That's overfitting.
So bias is too simple, variance is too complicated. We need balance?
Bingo! That's the bias-variance trade-off. Find the sweet spot where your model isn't dumb or paranoid.
Phew, this was intense. Can we now build a confusion matrix?